Nitrogen. Okay. Now, we talked about carbon. Listen up, please. And when you look at your three main biological molecules, and when you think about what these are, you can just think about what they always talk about in diets. You know, that's a very common subject, of course. Everybody's concerned with their diet, etc. But what are the three things they talk about? What are the three main types of food they talk about? Proteins, carbohydrates, and fats. Carbohydrates are sugars. Fats. Proteins, carbohydrates, and fats. So carbohydrates and proteins are mostly carbon, hydrogen, and oxygen. Okay. Proteins are also mostly carbon, hydrogen, and oxygen, but they also have a large amount of nitrogen. So that's the main role that nitrogen plays in biological systems, but it is also a primary component to nucleic acids like RNA and DNA. So it is kind of the third most common thing you'll find in living systems. And but most of the nitrogen that exists on Earth is actually in the atmosphere. Anybody remember how much or what percentage of the atmosphere is nitrogen?
74.
A little bit more.
80.
About 80, yeah, 79 to 80 in that area. Okay, so 79 to 80% of the Earth's atmosphere is nitrogen. It is nitrogen gas, so I'll go ahead and take that answer. But what is the formula? What's the formula that nitrogen gas takes? N2, right? It's a diatomic molecule. It's one of the Brinkelhoffs. You guys remember that from chemistry? Or if you want to talk about Brinkelhoff? Anybody remember Brinkelhoff? Nobody learned that? Nobody. Bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Maybe alluded to something out there. I think that was it. Anyway. So, all right, enough reminiscing about chemistry. So nitrogen is one of those, and it is a diatomic gas. It's a very stable substance. We talked about that when we talked about the atmosphere. How it's kind of like a nice neutral thing to help stabilize the atmosphere. But because of that, it's not available to I would say most living organisms, because life is about chemical reactions, and things that don't chemically react very well, you have to have certain special enzymes and stuff to make them do that. Fortunately, we have bacteria that can do that kind of thing. They fix it. Not that it was broken, but when you fix things, and we're talking about nutrient cycles and what they call biogeochemistry. I think I put that word on here somewhere. Did I put that on here? Well, anyway, how we do those different things. Fixing is when you take an element that is normally out in the environment or isn't out in the environment and put it into living systems. So photosynthesis in trees, for example, and other plants, and through the process of photosynthesis, fix carbon. There are bacteria who, through a number of different processes, we're not going to go into the details because it's mind-boggling, but they fix nitrogen. They take the nitrogen gas out of the atmosphere and they put it into themselves, and then they end up making it into a form that the plants can use. Okay? So this is the big part of the nitrogen cycle there. And the second major part of the nitrogen cycle is through decomposition. So this is where we first start seeing the decomposition process have a big impact on making nutrients available to producers and therefore the rest of the food chain. So, like I said, the first step is getting it out of the atmosphere itself. And we call that nitrogen fixation. It starts with nitrogen gas into, and through a number of different reactions, bacteria will convert it into both ammonia and nitrogen dioxide, nitrites and nitrates. Excuse me. Sorry about that. Nitrites and nitrates. That's why I got the X there. NO2 and NO3. But in this case, they're not the gases NO2 and NO3. They're the ions NO2 and NO3. So it's very confusing, I know. But this is a NOx. But in this case, it's not a NOx gas. It's a NOx that's dissolved in water. Let's do this. Let's put Put a little negative sign up here. So that'll help you maybe, hopefully, remember that's an ion, not a gas. Okay? Both NO2 and NO3 are -1, by the way. Okay, so that's done mainly by bacteria, but there's a pretty fair amount of this actually that also happens with lightning. In the case of lightning has a high enough temperature and everything that it can react the nitrogen and the oxygen that's in the air right around it. Just like we see happens inside automobile engines and high temperature furnaces. And then produce one of your gaseous nitrogen oxides, which then reacts with rainwater, producing both your nitric acid as acid rain, but also means that it will rain down nitrates from when you have electrical storms. Okay, but by far the biggest component, the biggest part of it is your bacteria that do this. Okay. Now the next one, assimilation. This is what plants do in general. So this is a general term. In this case, we're talking about it for nitrogen, but it's also what plants do when they make, for example, the glucose from photosynthesis into cellulose. It's when plants build biological molecules. That's what assimilation is. And when I say biomolecules, biological molecules, the main ones, once again, fats, proteins, carbohydrates. Okay, those are your biological molecules. And I've talked a bit about this, about how they're different than the individual, than the carbon dioxide or the nitrates and nitrites, and what we'll see, sulfur and phosphorus. And that's a connection. Those have to be broken down for the plants to get it back. Okay. So the plants put all this together, they make biological molecules. That's carried out by plants, or more accurately, primary producers, because we're also talking about algae as well. But these, so that's what they do, and they of course get eaten. Okay, they get eaten, and now we've already talked about the carbon cycle. So that part they got eaten, and then we exhale out the carbon dioxide. Now we're going to talk about urine. So don't get pissed. All right. We excrete the nitrogen after we break down our foods and stuff, primarily in your urine. Okay, as well as other organisms, and they excrete, if they're simpler organisms, they just excrete it directly out. But the point is that nitrates are water soluble, so when water is carried out, it carries waste products out. This is a big part of the waste. And then bacteria will take the nitrogen containing compounds in there. The main one is urea, as you might imagine, but the bacteria will convert it into ammonia. Ammonium, actually, we'll say. Okay? And then, so that's there. Now, plants can use that a little bit, but most plants, the easiest nitrogen form for plants to utilize is your nitrites or nitrates, your NOx's. And once again, let's put this.
What?
NOx, which can be nitrites or nitrates, which is nitrites or NO2, and nitrates or NO3. So I just, okay. So these are dissolved nitrogen-containing compounds. They're in the soil. It's what we use when we use fertilizer. As a matter of fact, the most common fertilizer is ammonium nitrate. So you get both forms of it when you put that down. It's also very explosive, but and that dissolves in the ground, and plants can take that up readily. And that's by far the biggest input of that nitrogen is from what we do by making those fertilizers. Okay, but in nature, bacteria will do this. They'll convert ammonia into nitrites or nitrates. That's called nitrification. Okay. Now, I didn't name these, so I don't know why denitrification is not. Okay. Chemically speaking, is not the opposite of nitrification, but it's not. Another thing to add something else to the whole picture that happens is in the soil there are bacteria. Put that in there. I don't have that. That convert nitrates and nitrites back into nitrogen gas and N2O. So it's really the nitrogen fixation that is the opposite of. So rather than me, I would have called this nitrogen breaking, but I guess they don't like my ideas. But it's the opposite of fixing it. They're taking it out of living systems, basically putting it back into the atmosphere. Okay. So the nitrogen, when that happens, is not a big deal, but this, I would be happy if you remembered that that is a greenhouse gas, so either group 2, either you remember that, or, oh yeah, by the way, that should be a subscript there. Or you're just guessing at it, but that's good. There was 4 main greenhouse gases we talked about: CO2, methane, N2O, and CFCs. Okay.
What's the last one?
CFCs. I review a lot, like, you know, when I'm kind of just conversing, so to remind things. So, you know, that was CFCs were back when we talked about global climate change. So anyway, there's our N2O. So that's part of the whole global climate change. I think I discussed this. I briefly referenced that we increase N2O through using fertilizers, which is what we do. When we put down these nitrogen-rich fertilizers in the soil for agriculture, we increase the amount of this denitrification that goes on, and therefore add more N2O to the atmosphere, and N2O is a greenhouse gas. And so we know the problems with that. Thanks. People who are introducing nitrate and ammonium fertilizers. Usually it's just both of them together. Like I said, the most common fertilizer is ammonium nitrate. But we put a lot of other stuff on the soil as well. But, and we also, if you may remember from air pollution, we produce nitrogen oxide gases, both through automobile combustion and the kind of high temperature furnace combustion you'll get in fossil fuel plants and steel mills and stuff like that. So under very high temperatures, you can make the nitrogen and the oxygen, or pressures like in an automobile engine, react the nitrogen and the oxygen together and produce your nitrogen oxide gases, your NOx. Okay. It causes pollution. You know what, group 4? I'm sorry, it's too big. Too late in the year to be taking extremely general answers. What specifically? What type group of pollution that causes a particular process to happen because it fertilizes the lakes? Eutrophication is what I was looking for there. And as I just mentioned, in the soil, the bacteria, the denitrifying bacteria in the soil, eat that, consume that fertilizer also, and they give off the N2O, which is a greenhouse gas. Oh, look at that, I repeated myself. Oops, well, just said that. Burning fossil fuels gives us NOx. All right, and then, yeah, so also, NOx is NOx in the atmosphere, as we've talked about before. This creates an acid rain, nitric acid in the atmosphere. And it is part of it combines with your gasoline fumes. And this is what makes the photochemical smog we talked about with air pollution. That produces what, for example? Or anybody else remember a component of
photochemical smog?
Kyle.
I know, I was just repeating it.
Rise and shine. Anybody remember? We love it up there. We hate it down here.
Ozone.
No. Photochemical smog. Yes. Could you repeat the question? Ozone's one of them, and a bunch of other stuff and everything. That is a common problem. Any questions about nitrogen cycle? All right.